So my talk is going to be all about innovating with Open Generative AI. And so I'll start with basics of generative AI, which probably most of you guys already know, but then go into the heart of this talk, which is open sourcing and why we do it. What is the benefit for the community, for startups, for the ecosystem, and for Meta as well, because a lot of people don't know why it's beneficial for Meta. We'll talk about Llama 2 architecture and the model and go into details of that. And Llama is also a family of models. It's not just one model. So we'll talk about Code Llama, which is a code assistant model, which is fine-tuned based on Llama. We'll talk about Purple Llama, which is our safeguarding tool for creating responsible AI. And then we'll talk about responsible AI and why it is so important in today's world. And Joe and DJ briefly talked about it, and I'll go into more details around that. And then we'll talk about the resources, a lot of the things you need to take our models and actually build generative AI applications. So as you all know, generative AI is taking over the world, right? There are a lot of potential applications you can build using generative AI, large language models. Last year, obviously 1.5 years back, ChatGPT came out. And immediately after that, people started building all sorts of applications. Stability AI came up with text-to-image generation. And there was like a whole slew of companies which got started. And the whole ecosystem started. There's no doubt that future of generative AI is super bright, right? So starting with large language models, text-to-image generation, and then now there are like AI-enabled tools which are being created, and we'll go into more details around that. But these are at a high level, the highest or the most popular generative AI use cases. Summarization for large documentation, sentiment analysis, content generation, chatbot, and virtual assistant. And there's no doubt generative AI will be the most important technology over the next decade. But before we start into what all of this means, let's look at the generative AI track, right? It starts with the bottommost layer, which is the compute hardware. GPU manufacturers like NVIDIA, AMD, Intel design these chips for parallel processing. And this is crucial for intensive calculations in AI tasks. Optimized AI architectures are built using this fundamental hardware technology and enhancing the efficiency and performance in handling the AI models. And then you have software which is built on top of that. Then the most other important layer is the cloud and hosting platforms, which allows the fundamental hardware compute to scale. They provide a range of AI services from pre-trained models to customized machine learning solutions and so forth. And these are global infrastructure. So anybody across the world can actually use these infrastructure to deploy their models in generative AI applications. Then the most other important layer is the frameworks, which are built on top of this. So PyTorch, TensorFlow, these are frameworks to allow developers and empower developers with flexible tools for building and training diverse machine learning models. These frameworks offer extensive libraries as well. So to help pre-build models, so you can take these libraries, leverage them, and then enhance and fasten the process of building the generative AI applications. And the most important piece is the community. You have massive community followers on PyTorch and TensorFlow, which you can then just get support from. And there's wealth of resources out there for continuous improvement in AI development as well. PyTorch is currently the most popular framework. It's used by almost 80% of all new applications which are created, or not the application, but just the fine-tuning models and so forth. Everything is pretty much built on PyTorch. For people who don't know, ChatGPT was actually built using PyTorch as well. And Llama is built using PyTorch. And on top of those sits the models, the closed source models and the open models. The foundational models serve as a powerful starting point for building applications and offering a base for customization, fine-tuning the models on specific needs. So, and then there are model hubs like Hugging Face, where people fine-tune the models, host it so that other developers can benefit out of that. And then there's, again, community contribution for foundational models, hubs, and there's a dynamic ecosystem which allows you to do continuous enhancement, expansion, and improvements to cater the evolving AI needs. And then there is a whole slew of companies which are building tooling on top of that. That is end-to-end training services, and these are fine-tuning the model or taking the model and then doing RAG and prompt engineering and so forth. And there's obviously data as a critical component, and so there are data labeling and annotations companies as well, which are helping train these models. And then the final layer is the application. There's vertically integrated applications like ChatGPT, Meta AI, and so forth, which allows you directly integrate into your apps, or you can directly use it through an API. And then there are other apps as well, which are end-user, consumer-facing apps. A lot of Facebook's first-party apps actually use these as well, these features. So we use internally Meta AI to enhance a lot of the functionality within Instagram and Facebook app. And here you can see it's available on Edge, multimodality, and so forth. And RAG is one of the most important things people are using right now for prompt engineering to make these apps more successful. Okay, so let's start with the basics. So how many people have actually used a large language model, and especially Llama? Okay, so about 50% of the people. And outside Llama, anybody has used? Okay. I see the same show of hands. Okay. So let's start with the basics of how LLMs work. For most of you already know this, but LLMs typically are based on an architecture called transformer architecture. There's a paper written in, I don't know the year, but it was written by Google folks called Attention is All You Need. And most of these LLMs are based on decoder architecture. It's an autoregressive decoder models. What that means is LLMs generate the sequence of words, takes in a sequence of words as an input, and then generate the next token of or sequence of word in a recursive fashion. Actually, they are pretty dumb, but all they can do is predict the next token of word. And when they are trained with billions and billions of parameters and tokens, they become intelligent over time to understand what is the next word following this particular word or a sentence of the word. And that's how it is shown to represent the intelligence, which we basically all think that LLMs have intelligence, but they are actually really dumb. I think the heart of a lot of this stuff comes down to two models. One is the closed models and the open source models. Meta constantly believes that open sourcing brings in a lot of benefits to the ecosystem and to Meta, and we are going to talk about this. I started my career in early 2000, and I started building web applications on a LAMP stack. And people who have been here enough long, they know what LAMP stack is: Linux, Apache, MySQL, and PHP. And this was all open source. So I know I built a bunch of web applications 20 years back. They are still in production, and I'm sure many of you guys have done it as well. And the beauty about that time was, because it was open source, it was so accessible, we could all build innovations on top of that. I think AI over the next decade is going to be the same thing. Getting access to these open source models and building on top of that open source data sets, these are cleansed, pipelined, and so forth. There's a massive advantages to bringing in innovation in the world. And this is innovation globally, right? People who don't have access to cloud infrastructure, they can run these models actually on a simple MacBook as well. So I think open sourcing is the biggest advantage, and Meta sees that as a big driver of innovation going forward as well. I basically talked about this slide, but I'm going to reiterate that our goal is to democratize AI access to the world. And by doing that, we are going to open source a lot of tools, including our large language models. But along with that, there's like tons of tools which will come down the road, which will be all open sourcing. And we'll talk about this. So these are a bunch of core projects I'm really proud of at Meta, which we have built and open sourced. These were all started as a research project, became commercial projects. Some of them became commercial projects, but a lot of these are research projects, open source, and it allows people and developers, engineers, and data scientists to think through how these are built and then get inspired and use it in different technologies as well. Even though we have so many research projects, two of the most fundamental projects which have been very successful is PyTorch and Llama. And for people who don't know PyTorch, think about this. I love to give this analogy that PyTorch is like Android ecosystem. You take a framework, you use a bunch of libraries, and then just like building an Android app using Android SDK, PyTorch is used for building generative AI applications or building a particular large language model, okay? Or it could be used for computer vision, NLP, and so forth. PyTorch started in 2019. It was Cafe 2. There was like transition from Cafe 2 to PyTorch. And in 2019, it had a market share of about 20%. But it was competing against TensorFlow. Today, the market share of PyTorch is around 70 to 80%. Most of the foundational models are built using PyTorch across the board. And we want to do the same with Llama. We want people to innovate, take Llama models, fine-tune it, use it for commercial applications without any licensing fee to Meta or anybody else. Here are some of the high-level Llama's benefits. It's open. That means anybody can take the model, download it. They can, whether it's small business, medium business, a developer sitting in his bedroom, they can use it. Being open helps mitigate data privacy concerns as well. So you can host it in your own infrastructure. You don't have, none of this data comes to Meta or any other org. You can host it on-premise. You can host it in a cloud environment. Llama models are available across all cloud players. It's free. That means you can take the model, you can fine-tune it, you can use your own data set, change it, and then resell it or use it in your generative AI applications, which is super powerful. It's versatile. It comes in different sizes, and we'll go into that in more detail. So you can use a small model as well as a large model, depending on the use case. And it's safe. And we'll talk about safety a lot because that is at the core of what we do. Responsible AI is critical as we build this very powerful generative AI applications, which will drive the future. Now, you may be asking, like, what is in it for Meta? We spend literally hundreds of millions of dollars to train these models. These models are trained on public data sets, plus some licensed data sets. And why do we do it, right? The best analogy I like to give is Meta is a consumer business. It's not an enterprise business. Our consumer apps are used by 3.5 billion people. And a lot of innovation in these consumer apps are dependent on AI platforms. If we don't open source this, then we are dependent on somebody else's AI platform. And so there is a vested interest for us to open source this. There's other benefit, tangible benefit of open sourcing it. We get thousands of contributors across the world come in and contribute back to this open source projects. And we reap the benefit for our consumer apps, plus the world reaps the benefit. So there is a massive advantage. We almost think about, we have hired all these engineers for free, and they are innovating into the open source platform. Plus, it's a massive benefit for the whole ecosystem, from startups to mid-sized companies to large companies. Because there's a large ecosystem created, people find bugs, issues in terms of safety and so forth, And so they basically contributed back into the model. And plus, there is performance improvements. Again, the community helps us understand. So a lot of the open source inference engines, which are highly optimized, are built around supporting Llama and the whole ecosystem around open source. And then, because it's there in the community, they tell us what the errors are, hallucinations are, and then we are able to fix those and develop higher quality models into the future. So let's talk about Llama 2 a little bit. So we launched Llama 2 for research purposes in February 2023. And we were blown away with the demand for open source models. And so we basically then launched a commercial version of Llama 2, which is 40% more data than Llama 1, and it has twice the context length. Now, to be honest, it is already a year old, and it is becoming stale. So we do expect the future versions of Llama coming out soon. These Llama 2 models are fine-tuned based on over 1 million human annotations. What this means is humans have given feedback through RLHF, what is called as reinforcement learning, using human feedback back to the models, and we have taken that feedback and improved the models. And when we launched this was the best performing open source model. It is still in the top 5 open source models out there on the public benchmarks. So let's go into a little bit of detail of how these are trained. So we basically start with the pre-training data. This is all publicly available data set, which is there in our research paper. You can access it on GitHub. And then they are self-supervised trained, and then Llama 2 is built. So we basically do the pre-training process. Then they are supervised fine-tuned. So they are fine-tuned for instructions. So just like DJ and Joe mentioned about how they took the question prompt response pairs, we basically take the same thing from the Llama models and then fine-tune. We basically have that whole data set, use that to fine-tune Llama 2 models, and then build the Llama 2 chat models, which is also called as instruct models. And then we use the human feedback loop to get the rejection sampling and the PPO policy, which is a bunch of algorithms to get the best feedback back into the Llama 2 chat models. And that's how these models were built. So this is a quick recap on the bunch of releases we have done over time. It started with in July of last year, even before that in February, where we launched Llama 1, and then we launched Llama 2. We launched it with over 100 partners, and these are from big partners to small cloud providers as well, like Together, Replicate, and so forth. All the major CSPs, which is Azure, AWS, GCP, host Llama models. Then we had currently the latest number is over 100 million downloads, but there's also 15,000 plus on over 20,000 derivatives. So people have taken the models and customized it for their own purposes. And I have a bunch of use cases which I'll go through on how they have done it, which is pretty interesting to see. Purple Llama was released because we think that safety and safeguarding is paramount in building generative AI applications, and we'll go into more detail of that. And then we see huge adoption of Purple Llama as well with major players. They are using that as a safeguarding before they surface these models to the end user. And we also think that the hardest thing to build in generative AI is analyzing code. The hardest thing for humans to do is building code, right, and analyzing code. And same thing for LLMs. And so we launched Code Llama, where it can not only analyze and debug code, but it can generate code with a simple natural language prompt. We'll see that. And this is all licensed, pretty much available for free. we do have a caveat that if it is more than 700 million monthly active users, then they have to just contact Meta on how they are using it. But other than that, for the most 99.5% of the people, it should be free. This is also a different way to show how these models are pre-trained and fine-tuned. So it starts with Llama foundational models. They come in 3 sizes, 7 billion, 13 billion, and 70 billion. And the reason why we came up with 3 sizes is for a couple of reasons. One is we wanted to make sure that we have versatility across different use cases. So for certain use cases, you may just require a smaller model, which is faster and cheaper, but it may be less accurate in complex reasoning tasks. But for certain use cases, you may want accuracy as your paramount, most important thing as part of your application, so you can use the 70B model. But they are more expensive to run. So these models are fine-tuned, and you can see here, these are Llama 2 chat models, both pre-trained and fine-tuned. So we have 6 Llama 2 models, 3 of them for pre-trained models. So these are foundational models, what we call it as, which you can take it and deploy it, fine-tune it, and deploy it with your own data set. And then there are instruct models as well. Then we also launched Code Llama models. These were fine-tuned. So we took the foundational models. We fine-tuned based on 500 billion tokens of code. And then we did long context fine-tuning. This means we basically increase the context length, the input, which you can send it to the LLM, and made it Code Llama. And I'll get to why this is important. Super important to increase the context length for Code Llama. We also did instruction fine-tuning so that you can chat with Code Llama models in a natural way. You can ask, like, hey, generate this particular piece of code for Fibonacci series, and then it will generate this code. And because Python is such a popular language, we actually fine-tuned it further with Python code training with 100 billion tokens, and then you have a specialized Code Llama for Python. This is a brief ecosystem of our partners. It's important to see this is because, it's not just us who are building this. It's entire consortia building along with us. So all these partners have supported Llama models or are actually using it. So Dell is using it for on-prem, which is a very unique use case, and they actually have hundreds and thousands of clients. They are basically taking that architecture and actually deploying. These are platform tools. Some of these are pretty familiar with you, like Hugging Face. Kaggle is now part of Google, and so forth. And then NVIDIA, we have also started working with AMD and Intel and so forth as well. So let's take a real use case. This is a real use case. It's all open sourced. So Meditron is the name of the project. There's a partnership between Yale and Swiss Federal Institute of Technology called EPFL. The goal was to democratize access to medical knowledge. So they took the foundational Llama 2 models and then fine-tuned it based on publicly available data sets, and they called it as Meditron 7B and 70B SFT based on Llama 2. The data sets used were based on, again, publicly available data sets, PubMed, papers, abstracts, and these are like literally billions of tokens, hundreds and thousands of abstracts. They were all taken in. So this is the architecture here. So these are basically how they took all this data and then send it to the pre-training model. So they basically send it this data to pre-train the model. Actually, the reason why I'm seeing here is because I can hardly see my screen here. It's so small. And then after they pre-trained the model, they did the checkpoint and performance and monitoring. And you can see nowadays, like, there are a lot of startups which are actually spending a lot of energy here. And once you're fine-tune the model, how do you evaluate the quality of the model, the output of the model? And then it basically became an aligned model, which is also an instruct model. And then they further fine-tuned it, supervised fine-tuned it with human feedback. So this is the process of RLHF. Also, we'll get into like distributed fine-tuning. This is super critical. When you have large data sets, you can't do it on one single GPU. You need to have multiple GPUs. And PyTorch, which is the framework we talked about, provides those libraries called fully sharded data parallel, FSDP, where you can take in multiple GPUs and train these models in parallel. And then you get basically the final version of the LLMs, and then the evaluation process is on the right. They have, and so they have created these, they've open sourced pretty much everything here. You can go to this URL, and you can just search on Metatron, and you'll get it. And they have basically done everything based off of Llama and PyTorch. There's this second use case. So for people who don't know, Jio is one of the largest companies in India, and they are a telco company, commerce company, entertainment company, and they use the Llama models. They actually started with ChatGPT, and they found that the cost was pretty high. It was cost prohibitive for them to use ChatGPT. So they took the Llama models, and they found it super cost effective, plus privacy, and they got a lot of community support. They started with prompt engineering. They modified their incoming prompts to do the task, but they found that to be limited. So then they used fine-tuning using PEFT, which is parameter efficient fine-tuning, and QLoRa. So here's the process they did. They cleansed the data. They got the data set, which then they used it for Llama 2 model, fine-tuned the model, and then performed the model evaluation, customized the model, and then deployed models in a distributed fashion. And on the right side, you can see how they have a single model, which actually transfers the intent to multiple models based on the user's input. So it acts like a router. And then depending on whether it's a instruct prompt, so somebody wants to chat, then it would send it to the chat models. Otherwise, if somebody's asking for information, then it would just send it to the intent model. So we talked about Llama, but the critical piece is also PyTorch. If you take the foundational model, there's very little use of that. You have to fine-tune the model to to make it custom for your own specific needs. And for that, you use PyTorch. So again, PyTorch is open source. You can go to pytorch.org and see all the libraries and everything and tutorials on how to use it if you have not used it. So there are a bunch of things here. First is PyTorch offers a unified solution. What that means is it lowers the engineering effort by providing user-friendly, automated, low-config APIs for you to do it. It provides distributed training packages such as FSDP, which we just talked about, which increases cost efficiency, letting users train these models in parallel fashion so you can do more with less compute. It also has libraries like torch.compile, which optimize the code to run faster, both for training and inference purposes. And then there's like better accelerated transformers, and these are also at the hardware acceleration layers for inferencing and so forth. And I also mentioned about parameter efficient fine-tuning and quantization. So PEFT is it's one of the ways to do fine-tuning without losing a lot of the memory, what we call it as catastrophic forgetting. It is an efficient way to fine-tune a model without changing a lot of the previous behavior of the model. And quantization is a way to lower the memory footprint for the model. And there are multiple ways you can lower the footprint of the model. One is quantization. Another is distillation as well. These are different algorithms on how to reduce the footprint so that you can use it on edge devices, mobile devices as well. And PyTorch, along with Hugging Face and a bunch of other, provides libraries for out-of-box libraries to do that. These are some other success stories, which I won't go into details, but we have Shopify using this for their small business owners to create commerce content, ads, and so forth. They also created a chatbot, which they have deployed to like thousands of businesses. And then we have other companies using it as well. And this is all available on our website as well. You can look at this deep level case studies plus technical collateral to understand how people have done certain things. So let's go to CodeLllama. By the way, that image is generated through imagine.meta.com. If you have not visited, go and visit it. You can generate free images there. So CodeLllama is an AI model built on top of Llama 2, which is fine-tuned for generating, analyzing, and debugging code. It's free for research and commercial use. These are state-of-the-art models, and essentially for code enhancement and capabilities. You can give natural language prompt, like write me a function that outputs the Fibonacci sequence, and it will generate code for you. And it supports multiple different languages like PyTorch, C++, Java, PHP, and so forth. So here's the high level. So CodeLllama is based from the foundational Llama 2 models. It was fine-tuned based on code tokens. And CodeLllama Python plus any CodeLllama libraries, so both one you see here plus CodeLllama are currently integrated into IDEs as well. So if you're using IntelliJ or so forth, and if you're not using copilots, assistant copilots, there are different names for this, please do. You can use, it can help you generate code faster. And there's a code chatbots as well. And that's why we basically build the CodeLllama instruct models, which are used for chatbots. So you can kind of converse with the assistant to help you understand certain piece of code. So you can copy a piece of code, paste it, and then ask the CodeLllama to actually analyze what is that code about. So we saw the previous slide, but CodeLllama is additional 500 billion tokens purely for code and 1 trillion tokens for 70B models. Based on human eval benchmarks, we have seen these are outperforming ChatGPT 4 in terms of coding assistance, and it is free for research and commercial use. Now, one of the most important things is the 100K token size. This is really important. So our Llama models have token size, incoming token context length of 4K, but this one has 100K. And the reason why we have this is because you sometimes have large code files, right? A PHP file or a Python file. And you should be able to take the full file and send it to CodeLllama to analyze or debug or generate a function. So if you want to generate a function, if it cuts off the upper portion of the file, which has all the imports and everything, it's meaningless. So that's why we basically support 100K tokens, which means almost 500 lines of code it can take in at a given moment. And it will not lose the context. You can generate code. You can debug code and so forth. So that's the biggest power of CodeLllama. Our future versions of Llama models will also have higher context length. This is the #1 feature ask from the community for us. So let's go into Purple Llama. Again, these are all family of models, like I said. Our goal is to continue to build on this foundational models and give the community both coding ability, taking our models, fine-tuning it for your own purpose with your own data sets, and then also safeguarding it. So our goal with Purple Llama, it's an umbrella project featuring open trust and safety tools and evaluations to help developers build responsibly with AI models. And so our inspiration was from cybersecurity concept of purple teaming. Purple teaming embraces both offensive, which is the red teaming, and defensive, which is the blue teaming. And if you merge red and blue together, it becomes purple. So that's why we named it as Purple Llama. Our goal here is to empower developers in deploying responsible AI applications, giving them the safety tools and evaluations so that they don't have to build it from scratch and figure out how to make sure your generative AI applications are safe. And we are not doing this alone. We are partnering with tons of companies, and I'll get to that in a bit. So here's the basic approach. You have a use case. We want to make sure that once you fine-tune the product, you take safety evaluations in consideration as well. And when you actually have the input and output going into your models, you also make sure that there are safeguard tools. Okay, so I have only a few more minutes, so I'm going to go quickly. So the umbrella project has two things. One is the CyberSec eval, which is a benchmark for evaluating cybersecurity risks of large language models. And this is a typical process where you take a large corpus of code, detect code with pattern matches, and then instruct LLMs to translate to instruction and check if LLMs are generating secure function with the instructions. And the second piece is the Llama guard, which is, again, a fine-tuned model from our Llama model, which is mainly used as an input guard and the output guard. So any inputs coming from the user, you can see in these blue boxes right here, that these are Llama guard models. It provides additional safeguards beyond what Llama provides. And this is, again, we have a taxonomy. We have 6 taxonomy. You can, depending on the applications, so for healthcare, you might need more. For certain other applications, you might need less. You can customize this completely. And it has shown to perform much better than any of these other OpenAI standards or Perspective API as well. Okay, I'm going to breeze through this, but at the heart of all the work we do, we want to make sure that responsible AI is critical. And so we make sure that we do red teaming, we evaluate our models, both during fine-tuning stages, pre-training stages, and so forth, for any harmful content. And we also basically open source, and we have released a guide called Responsible Use Guide, which is here, which has all the processes of what we have done and all the things which developers should do to make sure that your applications are safe. And like I said, we are working with the entire consortia. So IBM and Meta has started an AI Alliance, which has over 50 members on that team. And we are basically making sure that most of the tools and frameworks are open source and also working on safety standards. So here are some of the resources. If you don't get anything from this talk, make sure you take this, because everything I said is in Getting Started Guide here. Everything about accessing the models, fine-tuning, how do you do quantization, prompt engineering, and so forth. You can also search on Llama Getting Started Guide, and you'll get there. And this is also very critical, Llama recipes. This is a GitHub repo, which my team has built. And this allows you to take any model and fine-tune it. Meditron and Geo basically use this GitHub repo to build their use cases. So you can also use this. Okay. And Jeremy Howard, if you don't know, he's the founder of Fast AI. He loves this repo. And we have like almost doubled now the number of stars and the forks. And I just did a deep learning course with Andrew Ng about 3 weeks back. It's a really good course on if you want to learn Llama. This is like super basics on formatting and so forth. So you can go to this course as well. And I have my LinkedIn and GitHub as well. So as you build your applications, if you have issues or you have questions, feel free to reach out to me. All right, thank you.